In this video, we'll be covering the Unit 5 review packet. This video will be broken down into two parts, with Part 1 corresponding to pages 1 and 2, and Part 2, pages 3 and 4. Answer the following given the triangle ABC is congruent to triangle DEF. Hint, draw a picture. Okay. First, I'm going to draw a picture. We'll label one triangle ABC. And then in my second triangle, because the order goes A, B, C, that means A's corresponding part will be whatever comes first, D. B's corresponding part has to be the second one, E, and C has to go to F. So it means A and D correspond, B and E correspond, F and C correspond. How many pairs of corresponding parts do these two triangles have? 6. Each triangle has 3 sides and 3 angles. So that's 3 pairs of sides plus 3 pairs of angles would be 6 total parts. Number 2, segment CA is congruent to CA and DF are corresponding parts. Because these two triangles are congruent, these two segments have to be congruent. A slightly easier way to do it is take a look at the triangle congruence statement. C and A are the third and first letters of ABC. In this one, F and D will be the third and first. So this is congruent to segment FD. If CB equals 34, what other side has a length of 34? Going back to the congruent statement, CB are the third and second letters, F and E are the third and second letters. Therefore, CB corresponds to segment FE. And don't forget your segment symbol. What angle corresponds to BCA? Again, going back to my congruent statement, BCA would be second, third, first. Second, third, first would be EFD. If you were to look at the triangles, BCA is this angle here. Its corresponding part, EFD. Remember that order does matter. Which side is included by angle ACB and angle BAC? ACB would be this angle. BAC is up here. The included side between them would be AC. Another thing to notice is that in an angle, the vertex is always the middle letter. This has a vertex of C, this has a vertex of A. So the side between them would be CA or AC. Number 6, what angle is included by segment FE and segment DE? In our second triangle, FE would be the bottom segment, DE would be this segment along the left side. Where they meet is the included angle. That would be angle E. Another way to tell is E is the letter that these two have in common, so E has to be the angle that's included between them. Moving on. Identify the corresponding parts given a congruency statement. Triangle HOT is congruent to triangle DOG. TH are the third and first. Third and first here would be GD. Angle X. Angle X is the third letter. The third letter in the first one would be angle P. Segment GE. GE is the first 2 letters. The corresponding first 2 letters would be CA. PHO. 3, 1, 2 would be BDA. Topic 12b. Write a congruency statement for the following pairs of congruent triangles. As long as you have the corresponding parts in the same order, you can write each of these triangles in any order you want as long as they match up. I typically go for the single marked angle, the double marked, and the triple marked, just because it goes 1, 2, 3 and makes things a little bit easier. So S is the single marked angle in the first triangle. Its corresponding part would be S in the other one. Our double marked angle would be T in this one, and the double marked over here would be D. And then finally, our triple marks are U and E. So we have triangle STU is congruent to triangle SDE. We'll take the same approach here. Our single marked angle on the left is G, which corresponds to U. Our double marked is I, which corresponds to H. And our triple marked H, which corresponds to S. Triangle GIH is congruent to triangle UHS. Describe in your own words what it means for an angle to be an included angle. An angle is included when it's sandwiched between two sides. That's the key word here. In an example, if this was our triangle, and the sides we were talking about were these two, then this would be the angle that's included or sandwiched between them. Are the triangle pairs congruent? If so, give a reason, and additionally write a triangle congruency statement for 20 through 22. Remember, order matters. If you cannot prove congruence, state why not. Whenever we approach these problems, the first things we want to look for are any shared sides, vertical angles, parallels, or midpoints. The big two being vertical angles or shared side. And we'll mark those congruent. For number 14, we have that X, which indicates that we're going to see some vertical angles. These two would be vertical. The triangle on the left looks like it goes SAS, and the triangle on the right looks like it goes SAS as well. However, there's a problem. This single marked side is congruent to the other single marked side, which is in the exact same triangle. This double marked side is congruent to the other double marked side, which is also in the same triangle. So although this looks like SAS, it's actually not, because the parts of the triangles aren't congruent to each other, they're congruent to themselves. 15. I see a shared side in the middle, so I will mark that shared side congruent. I have side congruent to side, another side congruent to another side, and in the middle. So we have side, side, side. 16. We have a shared side in the middle. In this triangle, I have angle, side, angle, which corresponds to angle, side, angle in the second one. In order for ASA to work, the side has to be included between the two angles, and it is. This would be congruent by ASA. 17. Here we've got our shared side in the middle and a right angle. Normally, angle side side doesn't work. However, the case where it does work is when it's actually hypotenuse leg. If the two triangles are right triangles and the legs are, one pair of legs is congruent and the hypotenuses are congruent, then we can call them congruent by HL. Number 18, I see vertical angles in the middle. I can mark those congruent. So this would give me angle, angle, angle. However, angle, angle, angle is not a thing. You can't prove two triangles are congruent using only the angles. You always need at least one pair of congruent sides. So congruent, not enough information. 19. I've got a pair of sides and a pair of angles. There's no vertical angles because they're not touching. There's no shared side because they're not touching. There's also nothing marked as a parallel lines or midpoint. It takes three pieces to show triangles are congruent. We don't have enough information. Moving down. For 20 through 22, we have to mark the triangles ourselves as well as write a congruency statement at the end. We have AC is congruent to BD. So AC is the long segment in the middle, and BD is the long segment on the other side. If we were to use highlighters, we could outline the two triangles that they're talking about, maybe make it a little easier to tell what's going on. One of the advantages to using a highlighter is it makes it easy to see if there's any shared sides. At the bottom, this side is highlighted both orange and blue, meaning this is going to be a shared side. Finally, we have AC is congruent to BD and AD is congruent to BC. In these two triangles, we have three pairs of congruent sides. The first, the shared, and then the other part of the given. Yes, they're congruent. The reason, side, side, side. For our congruency statement, for my first triangle, we'll call this one ABD. Is congruent to. So if we went from A to B to D, the equivalent in the second triangle would be BAC. If you're not sure how to get the letters in the correct order just by looking at the picture, another way you can do it is by looking at congruent statements that you've already used. Based on this up here, A corresponds to C because they're both first in this congruent statement, and C has to correspond to D. If you look at the order these are written in, A does go to B in the second one, and C and D do correspond in the other one. 21. Here we have AD is parallel to BC. That is not marked, so we'll mark those as parallel. AB is congruent to DC. Means these have to be equal. We'll start with the easy one. Are there any shared sides or vertical angles? And there is a shared side in the middle. We only have two pieces, two pairs of congruent sides here plus the shared side in the middle, and we need three in order to show congruence. So the parallel lines have to be where we get our third piece of information from. Those are my parallel lines, and my transversal needs to be a part that's shared by both triangles. So there's three potential transversals I could use: DC, DB, and AB. I don't want to use DC because DC doesn't give me any information on the bottom triangle. And for the same reason, I don't want to use AB because that won't give me any information on the top triangle. However, DB is present in both, so I'll use that as my transversal. Here we have a pair of alternate interior angles. They're inside the parallel lines, but on opposite sides of the transversal. If we wanted to, we could also call these alternate interior angles as well. Either way, we have enough information to show congruence. I have angle, side, angle. Congruent, yes. Reason, ASA. I could also do this problem a slightly different way. If I'd only used one pair of angles, I could also call this SAS. Either way is fine. For my congruency statement, we have triangle ABD. A corresponds to B, so we'll call this triangle B. D corresponds to C. And then the third side, CD. 22. D is the midpoint of BC. In this triangle, we've already got two sides marked congruent, these two angles marked as 90-degree angles. It says D is the midpoint of BC. That means that the distance from B to D is exactly the same as the distance from D to C, because it's the midpoint. So we'll mark that congruent as well. When we have a right angle, we should usually check to see if we meet the criteria for HL, hypotenuse leg. A pair of legs that are congruent, that would be BD and DC, and the hypotenuses are congruent. Hypotenuses are opposite the right angles, so this would be a hypotenuse, and so would this. Another way to think about it is this is ASS, and ASS only works for right triangles, which these are. So congruent, yes. Reason, HL. For my congruency statement, ABD is congruent to, and then the equivalent parts or corresponding parts would be ECD.